All right, finally, the last video of Unit 4. This has been a long one. So, this last one is on the limitations of buffers and buffers in biological systems. So, I've already kind of mentioned this, but a limitation of a buffer is that it only works when small amounts of acid and base are added. You can't overwhelm it. So, if you have a 1 molar acetic acid buffer with its conjugate base, if too much hydrochloric acid is added, then all the acetate ions will be used up and there will be excess hydronium that you can't buffer, right? So, if you take something like the CH3COOH, which is in equilibrium with hydrogen ions and that conjugate base, right? If I shift left, but I consume all the hydrogen ions that I can, right? And really what it is if I use up this conjugate base, right? And I can't combine it with hydrogen ions anymore, then there's going to be excess hydronium. So a clue might be that they add maybe 1.5 molar hydrochloric acid. Well, it's too much. You've overwhelmed it. And what would happen is you'd have a drop in pH, the buffer would fail because you've exceeded the buffer capacity. End of story. So just little bits. Another thing is that what are some common uses of buffers? So, calibration of pH meters, industrial reactions, swimming pools and hot tubs, wine making, right? You have to make wine at a certain pH, pH balanced shampoos, which are supposed to neutralize things. Or keep not neutralize, but keep you at a certain pH, soil pH control, water treatment. There's tons, on and on and on. There are a ton of uses of buffers. So, what we're going to focus on here is just one application because those of you going into medical fields might be interested that there are buffers in our body. So, one of the examples of buffers in a biological system is to do with hemoglobin and oxygen transport. So blood pH has to stay close to a pH of 7.35. So it's like slightly basic for hemoglobin to work properly. Now, what does hemoglobin do? Well, hemoglobin, HHB, attaches to an oxygen molecule to form hydronium and oxyhemoglobin. And oxyhemoglobin is how we transport oxygen around in our body. So, how this works is that in our lungs, there is a high concentration of oxygen. So, that's going to shift our equilibrium to the right, which means more oxyhemoglobin is formed. Blood becomes oxygenated, right? If you have lots of this, we shift right, we form oxyhemoglobin, and then this blood is being transported around our body. So it's going to leave our lung area and enter our tissues or our cells where the O2 concentration is actually low because oxygen is one of the reactants in cellular respiration. So, in those areas where oxygen is low, all of a sudden the equilibrium shifts left so that the oxygen can be released in your cells. It's kind of like going from an area of high concentration to an area of low concentration, right? So, you've got high concentration of your lungs, you've got low concentration in your tissues, and it's released in your tissues, but it's more complex than that. But this balance is essential for proper oxygen delivery in your body. If you have a pH imbalance, so if your pH drops lower than 7.2, we call this acidosis, and your hydronium concentration is too high. If your hydronium concentration up here is too high, then you can't shift right? It's going to make you shift left, which means you're not forming enough oxyhemoglobin. So your tissues will not become oxygenated. So think about when you have a buildup of lactic acid, right? And your hydronium concentration is too high, you're not able to oxygenate your tissues properly. The opposite of this is alkalosis, which is when you get to a pH higher than 7.5. It means your hydronium concentration is too low. So your equilibrium can't shift left so that you can't release the oxygen into your cells. Right? So acidosis, alkalosis kind of do the same thing. Acidosis, you're not able to carry the oxygen to your cells. Alkalosis, you actually can't release the oxygen into your cells. And both of these can be life-threatening. So what do? Well, we buffer it. The blood buffer system is a carbonic acid and bicarbonate buffer. And what happens is that carbon dioxide, which is produced during respiration, dissolves in blood. And you've got this carbon dioxide in water forming carbonic acid, which is in equilibrium with its conjugate base, which is bicarbonate, and hydronium ions. So there's kind of like a precursor to this buffer. So we have to keep making this buffer so that it works. So carbon dioxide with water forms this carbonic acid, and then carbonic acid is in equilibrium with bicarbonate as its conjugate base. And this acid buffer system keeps blood near that 7.3. But what'll often affect this buffer system, right? So we don't want acidosis, we don't want alkalosis, we don't want to overcome this. And another example of breaking our buffer system would be hyperventilation. If you hyperventilate, you're exhaling too much, right? You're like not getting enough exercise. That was probably really awkward, sorry. There's too much carbon dioxide is lost. So if you lose carbon dioxide, then your equilibrium is going to shift left. Now this whole thing shifts left. So your hydronium concentration will actually decrease. It's a bit of a chain effect, and your pH will increase. And so if you have this increase in pH, then all of a sudden, if you think back to up here, right? So we are decreasing our concentration of hydronium. You aren't forming oxyhemoglobin, and then that oxyhemoglobin will eventually not be able to get to your tissues. And so you'll faint because oxygen cannot be released to the cells. We cannot shift left because we're so far shifted right. And so we can breathe into a paper bag because we want more carbon dioxide. And then eventually we'll come back into pH balance, and then we'll start oxygenating our cells again. Now, again, you're not going to be tested on this, right? This is a lot of information. This is more of like a, hey, you're learning chemistry, and chemistry is the basis of a lot of different topics, maybe like biology, or maybe you work out and you want to understand why your tissues are reacting the way they are, or maybe you want to understand why breathing into a bag helps with hyperventilation. And if you wanted to, there'd be tons of videos that you could see this in action, of watching someone animate this blood buffer system, because it's kind of cool. All right, good luck.